Here it says if you are rolling a die and your goal is to roll a 4, the probability of success is 1/6 and the probability of failure is 5/6. And that's because there are 5 ways you can roll something other than a 4. So 5 out of 6 possibilities. And there's only one way that you can roll a 4. That's 1 out of 6 possibilities. So that's how they got those probabilities. Now the question is, if you're rolling the die 10 times, what is the probability of rolling a 4 exactly 3 times? So we're going to use the formula there under step 2. So our first step is to identify the variables, what n is, k, p, and q. So n is the number of trials. So it says out of 10 times, if you roll the die 10 times, so that is our number of trials. And k is the number of successes that we're trying to find the probability of. So it says out of those 10 times, you want to find the probability of rolling a 4 3 times. So that is what k is. And then P is the probability of success and Q is the probability of failure. So it says the probability of rolling a 4 is 1/6 because 1 out of 6 sides is a 4. And the probability of not rolling a 4, so a failure, is 5 out of 6 because 5 out of the 6 sides is not a 4. So now let's substitute these numbers into the formula in step 2. So now we need to start to simplify this. First, we are going to use this binomial coefficient formula in step 3 to simplify this 10 over 3. And so let's substitute that into this formula. And once we substitute that in, then we start to simplify. So first I'm going to subtract this 10 minus 3. That's the same as 7. And then I'm going to expand these factorials. 10 factorial is just counting down from 10 to 1 and multiplying all those numbers together. And the same for 3 factorial. That's just 3 counting down to 1 and multiplying those together. And 7 factorial is 7 counting down to 1 and multiplying those together. Now, I could multiply all my numerator and all my denominator and divide, but instead of doing that, because I'm going to be dealing with some pretty big numbers, I'm first going to look to see if there's anything I can cancel out. If you see a number in the numerator and the denominator, then you can cancel it out, because like this, 7 divided by 7 is 1. And then 6 divided by 6 is 1, and so on. So I'm going to cancel a lot of this out because there's something in the numerator that matches the denominator. So that is equivalent to 1. And then when you have your numbers that are left, we're going to multiply our numerator and our denominator and see what we have. And then we can just simply divide. 720 divided by 6 is 120. So what we have found out is this is the same as 120. So I'm going to rewrite my formula, my equation here to find the answer of from step 2, but instead of this, I'm going to put 120. Then we're just going to continue to simplify this further. First off, this 10 minus 3, I can just subtract that. That's the same as 7. Then these exponents here, this is not just for the numerator. This is for the numerator and the denominator. So I'm just going to rewrite that and put those exponents on my numerator and the denominator, because it's like this whole thing is to the 3rd power. This whole thing is to the 7th power. And then I'm going to put these in my calculator and see what is 6 to the 3rd, what is 6 to the 7th, and 5 to the 7th. And then I'm going to divide these and see what I get. And then just multiply those by 120. And when I do, I get this. Now, what does that mean? If I roll the dice 10 times, what is the probability of rolling a 4 exactly 3 times? It's best, or it's most convenient maybe, or easiest to understand to change this decimal to a percent. So I would say there's a 15.5% chance or probability that I'm going to roll a 4 exactly 3 times out of 10 chances.